Aloha, Professor Teo, and this is my findings about the last two workshops of the report 6. I'm gonna start talking about the automatic control with the closed loop circuits and the localizer and the ILS. So first of all, what I know about what I notice about the automatic control is that we need to talk more about the Kalman filtering because this is explain of the how works the closed loop circuits in the aircraft because the value comparison used in the aircraft is based of the with the Kalman filtering at first. And thanks to Kalman filtering, we have other statement more than the measured and the predicted statement. In the closed circuit, we have a measured statement, and then with the recursive action, we have a predicted statement too. With the Kalman filtering, we could be better doing a optimal statement of the, for example, in this situation, the position of flight. The predicted statement make an other comparison with all the possibilities in the aircraft to make a optimal statement, and there is the calculation of that. So we need to we need to use an initial statement with the time update of the loop, and then the prediction shows a correction and the optimal position or the ultimate function we need to know about the alternative. With that, I would like to talk about more of the philosophy we use in the aircraft at A320, that we must know that the possibility we have with the A320 is that we could stop the automatic function of flight as needed, as the pilot needed, if there is a situation of error in the automatic system. So we can use the manual function as rapid as we need, only grabbing the side stick or only changing the throttle control level manually, and the system roll over or go off in the case of the automatic flying. This is good because we quickly changes in modes of automatication and the manual of the pilot as they need it. And the other is that we don't need to change the entire flight plan. We could always power up the automatic flight. And then I would like to talk about the localizer and ILS that I saw that we have two. There is a comparison in this lab that this is we have the AHRS, that is the attitude heading uh, reference system, and in the other hand we have the gyro. We have the gyro compass, the electrical gyro compass, in the case of we have been using in the module ABS. So the electrical gyro, the difference between the electrical gyro and the HRS is that the AHRS don't have don't have the problem of the precision error, like all we know in the gyros and the way that we use, they could get a precision error, and then uh, the AHRS uh, make the possibility to use that information with more precision and more data to use it as autopilot systems and flight directors, or as well as jump damper and changes in the flight data more precisely. And there is the more the more big uh, the more big difference between those. I also looked at that the the functions of the i320 in the closest loop circuits we using. It needs an AHRS. It couldn't work with the electrical gyro. So that's all. Thanks a lot for seeing the video, and see you in the next time.